Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic coordinate systems. Spherical coordinate system. A point in spherical coordinate system is represented by P of r, theta, and phi. In the previous lecture, we discussed about the representation of a point in Cartesian coordinate system. Whatever the point we represented in Cartesian coordinate system, we represent the same point in cylindrical coordinate system. In cylindrical coordinate system, it is represented by the coordinates rho, pi, z. In this lecture, we are going to represent the same point in spherical coordinate system. The spherical coordinates are rho, theta, and pi. It is the position of origin. It is the position of required point. The distance from origin to the required point is r, and the distance angle measured between z-axis and the position vector of OP is co-latitude represented by theta, and pi is the azimuthal angle which is measured in z equal to 0 plane, where rho is the distance in xy plane. The range of r is from 0 to infinity. The range of theta is from 0 to pi. Theta is co-latitude or the angle measured between z-axis and position vector of p. Pi is azimuthal angle ranging from 0 to 2 pi. Now it is the position of required point. To represent the point in spherical cylindrical coordinate system. For that, we have draw a line parallel to x-axis, which is perpendicular to y. One more line, draw a line parallel to y-axis, which is perpendicular to x-axis, and it is the distance along z-axis, and this line is perpendicular to xy plane. It is the distance of rho. It is azimuthal angle. If you consider a triangle, it is the position of 90 degrees. Let us assume it is the position of theta. Then the side opposite to 90 degrees is diagonal. And based on that, you can apply sine theta, sine pi, cos theta, cos pi as per your requirement. Now here in this triangle, if we apply cos pi, it is equal to x by rho, uh, x equal to rho cos pi. Similarly, y is equal to rho sin pi, and z equal to z. These three equations will give the relation between the coordinates of Cartesian and cylindrical coordinate systems. Now we are going to derive the relation between Cartesian coordinates and cylindrical coordinates. For that, draw a line which is parallel to xy plane. It is perpendicular to z-axis, and it is the distance in xy plane. Now from z equal to 0 to, let it be point r, is the distance along z-axis. It is co-latitude. It is also co-latitude. Now in this triangle, now apply cos theta. The value of cos theta is equal to z by r, means z equal to r cos theta, and similarly sin theta is equal to rho by r. So the value of rho is equal to r sine theta. X equal to rho cos pi. Now substitute the value of rho here, r sine theta cos pi. It will give the relation between x, r, theta and pi. Similarly, y is equal to rho sine pi. It is equal to r sine theta cos pi, and z equal to r cos theta. These three equation will give the relation between Cartesian coordinates and cylindrical coordinates. And once again, we can simplify r equal to root of x square plus y square plus z square. Theta is equal to tan inverse rho by z. It is also equal to tan inverse root of x square plus y square by z, where the value of rho is equal to root of x square plus y square, and regarding pi, it is equal to tan inverse y by x. By knowing the value of spherical coordinate system, you can determine the Cartesian. By knowing the value of Cartesian coordinates, you can determine the spherical coordinates. Once refer to the relation between xyz and r theta pi. Here the relation is in terms of cos. In terms of tan, it is tan inverse rho by z. Rho is equal to x square plus y square, and pi tan inverse y by x r theta pi. Differential length, differential normal surface and volume in Cartesian, cylindrical and spherical coordinate systems. Uh, in Cartesian coordinate system, you just remember 1, 1, 1. The differential length elements are dx, dy and dz, 1, 1, 1. The differential normal surface is given as the product of two in other direction, dx, dy and dz. Sorry, it is az cap, dx, dy, az cap, product of two in other direction, dy, dz along ax direction, and dz, dx along ay direction. The differential volume is given as dv is equal to dx, dy and dz. This is about dl, ds, dv in Cartesian coordinate system. In cylindrical coordinate system, you remember 1 rho 1. The coordinates are rho, pi, z. Here, uh, the differential elements are d rho, rho d pi, and dz. That is 1 rho 1, and ds is equal to differential normal surface product of 2 rho rho d phi along az direction, uh, d rho dz along arrow direction and d rho dz along a phi direction. The product of two in other direction will give the differential normal surface, and regarding the differential volume it is rho d rho d phi and dz. In spherical coordinate system, the coordinates are r, theta and pi, and here you have to remember one r sin theta. The differential elements are dr, d theta, d phi. You remember one r sin theta. The differential elements are dr, r d theta, r sin theta, d phi. Now the differential normal surface product of two in other direction r dr d theta along a phi direction 2 3, that is r square sin theta dr d theta, sorry, d theta and d phi along ar direction 1 3. The next is 1 3 r sin theta dr d phi along a theta direction. Regarding the differential volume, dv is equal to r square sin theta dr d theta and d phi. The vector transformation between Cartesian and spherical coordinate systems are given by the equations. Refer to the equations. In the next lecture, I will give the trick to remember the vector transformation between Cartesian and cylindrical and between Cartesian and spherical. Uh, the dot product of the unit vectors and the cross product of the unit vectors. You can follow the same procedure what you followed in Cartesian and cylindrical coordinates, that is AR, A theta and A phi. AR cross A theta is A phi, A theta cross A phi is AR, A phi cross AR is A theta. AR dot AR equal to A theta dot A theta is equal to A pi dot A pi is equal to 1. For the same, it is 1, and for the different, it is 0. Uh, the reason is A phi and AR, A theta and A pi, AR and A theta are perpendicular to each other. A vector in a spherical coordinate system is represented by the components AR, A theta, A phi, R, AR, AR cap. A bar is equal to AR, AR cap plus A theta plus A pi, A phi. The gradient of a scalar function in Cartesian, cylindrical and spherical. Once refer to the formula, I will give the trick to remember the gradient in the next lecture. The curl of a vector in Cartesian coordinate system, cylindrical and spherical. Refer to the formulas. The divergence in Cartesian, cylindrical and spherical coordinate systems. Refer to sample problem 1 and its solution. Sample problem 2 and its solution. One more sample problem. One practice problem. Thank you. We will meet with the next lecture.